Hello. Hi. So this talk will be about distributing systems with Scala in Fiangle. I'll explain what those are in the talk. So a little bit about myself. My name is Julio Capote. I work on the API team at Twitter. And my Twitter handle is @CapoteJ if you want to follow me or ask me any questions after this talk. So I'm going to go a little bit fast, so hold the questions to the end. I'll try to get to all of them. So we're going to talk about services and what they mean. We're going to talk about Scala. We're going to talk about Fiangle. And we're going to have a lot of examples so you understand what I'm talking about. So when we say scaling, it's important to define what we're talking about. Most of the time, it's associated with scaling to a lot of users. A lot of things that a lot of times people don't think about is scaling to developers. You can't have 2 developers working on a system the whole time. Eventually, you want to hire more people and do more things, so you have to figure out how to support this many people. So everybody usually just starts small. Very simple. You have the first prototype or the system that you launch that night. You put it out. It's good. People start using it. Eventually, you want to add more features to it. It needs to do more things. And then you get to the point where you just cannot add any more features, right? So you end up with the classic monolithic system. This is not very good because you're limited to a single language and runtime. So it may not be the best language for everything. So you're limited to that one thing. You can also only support very few developers. The bigger the system gets and the more features you add to it, the more dangerous deploys get because one feature can tank the whole deploy. So how do you solve this? Usually you split them up into many tiny services. When you go to Amazon.com, this page called over 100 internal services inside of Amazon to render everything from the recommendations to the top products for that day to different optimizations we're trying for different user groups, so on and so on. So this is called a distributed system normally, right? And the benefits of this is that you can write each service inside your architecture using a different language. So you can write things that are better suited for the individual tasks that they are doing. So it's also a good way to move a system that was traditionally written in one, maybe slower language, like Ruby or Rails, and then move it to something faster, like maybe Java, PHP, something like that. And also, a distributed system means you can support many developers because you can center developers around different systems. So some people only have to work on one thing. And this also means that you can deploy each service individually, right? But this gets very complex because you end up with something like this, where you end up having a bunch of services calling other services and other services calling even more services. So how do you deal with all this complexity? You can't have every developer understand how to make all the common things needed to make a service. You just want them to work on the application logic for that one particular service and be able to write these services. So you need some kind of framework, some kind of common ground that everyone can speak. This also makes profiling, debugging a lot easier, because if everything shares the same common base, then it's easy to rule out problems, because it would affect every service. So Fiangle helps with this, but we'll get to that later. Right now, I just want to do a quick Scala intro so you understand most of the examples are going to be written in Scala. So what is Scala? Maybe you haven't heard of it. So Scala is a new JVM language. It compiles down to Java Virtual Machine bytecode. It's interoperable with Java because they run on the same virtual machine, which means that you can have Java code calling into Scala code, and you can have Scala code calling into Java code, vice versa. And it's a functional language. Java is traditionally very object-oriented. Everything's an object, everything's a method, everything happens on an instance of that object. But Scala is also object-oriented too. So you get kind of the best of both worlds there. Some problems are easier to describe in a very functional mathematical sense, and others are they're better expressed in a object-oriented domain model type fashion. So let's get started. So you have values. These are simple. So you say here we have a value of foo, which is set to the string bar. Notice how the type comes after the variable, which is different from Java, where you say the type is in front of the variable. So here we say this is an integer of age, 27. But the thing is, what's cool about Scala is that you don't have to give the types most of the time. So we could just say this. So this is starting to look a little more expressive, a little more like Ruby or any kind of language that, a more modern language that doesn't have types. So that's the same as before. So you have standard collections. You have lists that can hold everything of the same type. You have sequences, which are just lists that have the semantics of being ordered. You also have dictionaries and hashes. This is a map from foo to bar. And then when I say functional, this is a good example. So we have here we have a value of add1, which is equal to a closure that takes x and then just adds 1 to it and then returns it. So we can apply this function by calling the apply method on it. So if we apply 2, you see we get 3. So since this kind of function application is very common in Scala, there's actually a syntactic sugar for doing so, which is just calling it directly on the value. So you just say that, it's the same thing. So here we're going to assign a list of 1, 2, 3, 4, right? And then now we're going to map over that list and call add1 on each of the values. So this will return the same list we had before, but with each value incremented by 1. So this is a very common thing. You do this all the time. If you're from Ruby or Python, this is like a generator. It's very similar. So you could also just say map and then give it the default argument, which is the underscore, right? Or you don't have to give it at all. Or you can simplify it by not even calling the dot on the thing, or not even the parentheses. So this is starting to look very simple and easy on the eyes to read when you're doing a lot of these on the same code. So here we're going to map through that list, add 1 to each of the things, and then we're going to filter out the ones that are even. So in Java, this would take, you'd have to have multiple loops to go through and do this. Here it's very simple to express this kind of operation. So you can also compose these functions. This will become very important later. So we'll have our, hold on, this froze here. Okay, there we go. So we have the add1 function we had before, okay, and then we have one that just adds 2, right? So we can create one called add3, which is the composition of add1 composed on add2. So now we can just call add3 to 2, we'll get 5. It's also object-oriented, so you can make your usual classes and extend with inheritance to find a method on that does something that makes sense for that class. So one of my favorite features of Scala, which does not exist in Java, but you can via the Guava library that Google has, but the Scala supports it natively, which is called options. You can have the concept of something or nothing wrapping a value. This is like an alternative to null, and it really reduces the amount of null pointer exceptions that a program can generate. So it's a mystery box, is a way to think of it. So here we have the map we had before of foo to bar, okay, and then we call get on the map, which is how we retrieve a key. So we say we want to get from a map of foo bar, we want to get the value for foo, right? So here, because the maps return options, we don't just get bar back, we get a sum of a bar. So this tells us that there was something in the box, right? But if we just were to do get on a key that wasn't there, normally this would be a null pointer exception and your program would throw the exception. But here instead we can get back a none. So what's cool about this sum and none stuff is that you can do, there are methods on these high-level options that you can express very common things. So a lot of times we want to do a default. So we get a key. So here, let's say we have the map of foo to bar for in A. So then we get the option, which is the get of the ZZZ from the map, which doesn't exist. You know it's not there. So, but in the code, you don't know that's the case. So we could say get or else, which is give me the thing that's inside of that option, or if it's a none, use this default. So we do this all the time in programming, in web forms, stuff like that, for filling out default values. This kind of stuff is prevalent throughout the standard library of Scala, and it's very cool to write code this way. So another thing that we could do with it is that we can pattern match on it. So we could say that, like, if the case is sum of x, just return that x. If not, then just if it's a none, make it the default. So there's various ways to slice and dice these options, and there's tons of methods on the option class that you can that will help you in these common scenarios. Another cool thing is that options are actually just collections. So you can think of them as collections that are empty or containing one value. So here we can for each over an option and print line the result. If the option contains something, it'll print line it. If it doesn't contain anything, the for each will just no op because a collection is empty. So this is also important later, and you'll see why. But for now, just see it. So now I'm going to talk about Fiangle. Fiangle is a framework that we wrote written on top of Scala using Netty to make all of our internal services at Twitter easier to write and reason about and develop. So what is Fiangle? It's a client-server RPC framework. You implement clients with it, and you also implement servers with it. And these servers can implement different methods, and they can call each other. It's asynchronous. Since it's written on top of Netty, everything is done in a callback fashion, and there's an event loop powering it, and you're not necessarily waiting on data from the server to come back for you to continue with your operations. You can easily specify the ordering of operations, and things will happen in the background when things are needed. So it's also functional. It embraces the philosophy of Scala and functions and composition and stuff, and you'll see this more in the examples later. It's also protocol agnostic. It doesn't care about what protocol you're speaking. So you can implement HTTP. We use Thrift at Twitter. We also use Memcache. There's a bunch of different protocols that you can implement on top of it. So it's very flexible. So let's talk about futures. This is the core concept of Fiangle, and this is our unit of currency when we're talking about concurrency in our systems. Okay? So what is a future? Whoa. A future is also a mystery box, just like options. You don't know what's in it. Not only do you know what's in it, you don't know when it's going to come back, just as the nature of a concurrent operation. You also don't know if this operation is going to succeed or fail, right? But because with these trade-offs, this is how we can enable multiple things happening at the same time. So let's get started with an example. Here we have a method called fetchURL. It takes a URL of a string, and it returns a future of a response. So just like options, a future is a container. You can have a future of anything, right? So here we just have a response class that has, you can imagine, like get content or whatever. So here we're going to assign, we're going to call fetchURL with google.ru, and we're going to return that into f, okay? Now we can, since futures are also collections, just like options, we can map over them, we can for each over them, we can do all the usual things we're used to with collections. But they have interesting semantics because they're talking about computations that have or have not happened yet. So here we're just mapping over the response. When that response eventually does get it, does come back, we're going to print line the content. Interesting to note is that the execution of this thread, where you're writing this, will just keep going. That map is actually registering a callback into our Netty implementation deep down inside, abstracted from you, the developer. So mapping is cool, but more useful is being able to specify what happens when on success or on failure. So here we're saying, if it actually succeeds, print it out. If it fails, log the error out. So let's talk about services and what they mean inside of Fiangle, right? So Marius Eriksson, one of the developers who works at Twitter, wrote an amazing paper called Your Server as a Function. It's just there's a link to it at the end of the slides where he talks about the philosophy of Fiangle and how this enables the development of concurrent services very easily. Okay, so if you can imagine your service, right, is a thing that has a request and a response, right, and it receives a request and it gives you a future of that response. Okay, this is like the core fundamental of like every server you build. Okay, so you have the request and you get back a future of that response. Okay, and this is actually symmetrical. If you think about an HTTP client, okay, we are giving you a request and then we get back the future of the response of that web page. So here we're creating a client service for google.com on port 80, or rather google.ru on port 80. And it implements, it's a type of a service request response, right? So the way we make a request on that is we make a request object called, for just slash, this is like, you could put headers here, any kind of params, right? We're going to save this off to rec, okay? And then we're going to apply this function with the request on the client that we created, and then we're going to say if that succeeds, print it out. So this is the same as applying, if you remember before from the example, right? So we're just applying a function. We're applying a request onto our client function and getting back the response when it actually happens, right? So here is a more explicit example. So we have the request, we have the client, we do the onSuccess. So one thing I'm going to introduce here is await, right? So I talked about before where since these are all callback based and asynchronous, these onSuccesses and on callbacks, the server is not, this thread is not going to wait for this to come back. So we have to actually, in the main thread, say that we have to wait for this to come back. If we're going to do this example, like normally you're running this in a server context, and the server is already waiting forever till you shut it down. But to make the example more complete, you have to actually say await ready on a future so that the main thread will pause and wait for that future. So here we have an HTTP server example. Right, so we have a server class that extends service request response. This is a class provided by Fiangle, right? And then you apply this request. We're implementing the apply here ourselves as opposed to getting it from Fiangle. So here we say when the server gets applied with a request, we're going to return a future value of a new response high. So future value is how you return a value immediately wrapped in a future. So normally this could be making a backend call, which itself will return a future, and you could just return that from the return of the apply. So you'll see this in a more concrete example later, and it'll make a little more sense. So again, this is the request future response fundamental here. So we start the server by creating a service with the class that we just defined. And we call http.serve with the port we want, and then we pass the service into it, and then we wait for the server to end, which is forever. So if we combine the client that we created before with the server that we created just now, we can actually have a pretty concise HTTP proxy. So I love this example because it shows you how easily it is to make things in Fiangle. So right here, this is an entire HTTP proxy. So we have a client that is the one we made before, which is the google.com RU on port 80, and then we make a server which serves this client out, and because the client is a service, we can just serve the HTTP client out as a server, and then just wait for the server to end. And this is a full proxy combining the client and server. So here we have the client, server, and then we wait. So another cool thing that Fiangle introduces is the concept of filters. So a filter is something that modifies a request-response pair on the way in, right? So the actual type definition for a filter is it's a filter that contains two request and response pairs. You have the inbound request and response, and then you have the outbound request and response that you're sending it out. Most of the time, these are actually the same type, so you can actually use a simple filter, which is you just give it two types for the request and the response, right? And then this is the apply contract that we have to implement as a filter. We get a request, which is the one that's coming in, and then we get the service that we are wrapping around. And then we return a future of the response. So here we have a filter called scream filter, which what it does is it's going to wrap an HTTP service and then add an exclamation point to whatever the return of the server was that we were wrapping. So here you can see that we're extending simple filter with the same types that we're implementing our service with, our filter. Right? We have the apply contract that we have to fulfill, which is the method definition. And so here we have the service passed in. And then since the service, we just apply the service with the request like we've been seeing in our examples. And then when that succeeds, we're going to go ahead and set the content of the response that we received before, plus the exclamation point, and then return that. Which, if you recall, a service returns a future response. So because this returns a future response, we can just return it, and it satisfies the type contract. So this is the example we had before, where we serve where we create and bring up the HTTP server. Now we're just going to add our filter definition in there, so store that off to a variable. And then remember when we talked about function composition, we're going to use function composition to compose the filter onto the service. And then it's actually the same thing. So one of the other core things about Fiangle is that it implements a very rich metrics system for you. So this lets you collect all kinds of statistics. Fiangle itself already collects a ton of statistics for you to help you debug your program. It gives you heap allocations, JVM GC times, all kinds of stuff. So if you were to bring up a Fiangle server, it usually listens on an admin port via HTTP. Even if it's a thrift service or a memcache service, whatever, it usually has an HTTP admin port that you can hit. And it exports all its metrics as JSON. And at Twitter, we have collectors that go through and fetch these JSON pages and then throw them into a database that we can then query to like draw graphs and plot things against each other and see how things are performing. So this is like an example of like some of how it looks inside. You can see that we collect very detailed metrics. P49s, P75, averages, maxes, mins, number of connections. There's a ton of stuff in there. You can also add your own. Here we have the server thing we had again. Now we are getting, we can pass a stats receiver into the server, and then we can call counter on it to register a counter that we're keeping track of this variable. And you could also do timers. So here we're actually doing we're timing this expensive operation under the key of fetch. So when we go to hit that JSON thing, we'll see a whole bunch of metrics under the key fetch for the P99 and the average and the count of those operations. So one of the good ways to get started with Fiangle is an open source web framework that I wrote called Finatra. This is the marriage of the Fiangle with the popular Sinatra-style web framework written in Scala. So here's an example controller that we have. So just like in the Finatra style, we say whenever we receive an HTTP GET to slash, we have that request passed into us, and we're just going to render a plain hi. Notice how this returns a future. So that's the stuff we've been talking about. So Finatra is also asynchronous. And then here's how we start that controller up. So we have a server that extends Finatra server, and then we just create a controller. We store it off, and then we register it to the Finatra server, and that's it. It will just start up. So this is the website. You can get more information on that. It supports templates, JSON, filters, metrics, all the stuff we talked about, and more. It's a good introduction to Scala. I wrote it to learn Scala myself. There's like an app generator. There's an example app you can play with. It's very easy to get started. So do you have any questions? I'm going to leave these links on the page here. So this is the Fiangle guide. It gives you much more information than I just gave about how to use Fiangle for writing client servers, implementing codecs, stuff like that. This is the paper I referenced earlier. Very good read if you're into that. And then this is the website for Finatra. So that's it. If you want to hit me up, Capote J.
Thank you. What are the main benefits of using Scala and Fiangle over other programming languages in the combination of web frameworks, for example, Python and Tornado Python with Twisted? What are the main benefits of Scala in terms of optimization or implementation?
Sure. Good question. You can use whatever you want. We, as a company, wanted to use something that was powered by the JVM. Historically, we were using Rails and Ruby. It would have been very hard to get the current developers to use something directly like Java. With Scala, you get a lot of the expressiveness that usually people like from Python or Ruby. But you also get the power and speed of the JVM, all the profiling tools, all the stuff that you're used to, plus a really good deployment of just single jars to servers, and it's just really easy from an ops perspective to admin and maintain Java servers.
Julio, how many services do you have on Twitter using this technology? And also, do you use like on the client side in JavaScript something like promises? There is the same concept in JavaScript also.
Yes. Every service we have at Twitter is using Fiangle. We have probably over 100 at this point, and more coming up all the time. As to the front end, whether we use promises or not, I don't really know too much about the front end stuff. I'm on the back end team, but I think that our front end frameworks implement something similar as well.
I would like to ask, how do you maintain the backward compatibility in the framework?
Network compatibility? I don't understand.
How do you maintain that? If you said before that you have many kind of services, and some of them became kind of old, and some of them became new. And how do you maintain these things?
Okay, so one of the cool things that Fiangle does is one of the things it gives you is connection pooling, and it gives you load balancing. So these are very simple examples, but in production, you can give them a list of hosts, or you can give them a zookeeper node to go and get the list of hosts from, and we do service discovery that way. And the client just knows that whenever it gets applied a function, it picks one randomly from the pool. And it's also, there's different strategies that you can configure to use, but one of the things it will also do is if it notices that a server is taking too long to respond, it will actually remove that from the pool on an exponential backoff to find out when it comes back, it'll throw it back in the pool. So there's all kinds of intelligent stuff happening inside the framework behind the scenes that are helping you write more robust distributed systems.
I have a question regarding API versioning. So does Scala or maybe this framework does they provide some facilities that you maybe publish new API version, and the client of the previous version will continue to work with the previous version?
Good. You're asking about whether different versions of the things are compatible? Yeah, they mostly are. It's actually up to the API provider and the client to not break each other, just like any other system. But there's nothing inherently that breaks just from using different versions. So like if the Thrift versions are incompatible, that's going to break, but that has nothing to do with Fiangle, for instance. Or if you change the HTTP route or the kind of parameters it gets. So we try very hard not to break things in between releases. So things are mostly compatible. No problem.
Hi.
Yes.
Do you have an example to inject Scala or Fiangle in existing Java project?
Yes. So if you go to the Fiangle guide, we have tons of examples that use Java as well. So because there are services at Twitter that use only Java, but they're also using Fiangle. So it's written for Scala, but it also respects Java, so you can use it from within Java. So we support both languages, even though it's a Scala library. Oh yeah, that's it. Thank you.